Okay, here's my video for graphing the piecewise function from problem number 11 on our chapter 1 practice test. And what I'm going to do here is what I do in any piecewise function graphing is I'm going to do two xy tables, one for the top function, one for the bottom function, and I'm going to choose my x values according to the domain they give me for both functions. So the first one I'm going to graph, first one I'm going to do an xy table for, is going to be this negative x squared plus 3. And that's going to be in that domain x needs to be less than 0. Well, remember, I talked about this in the lesson. When I do my xy table here, I'm going to include 0 in my xy table, but when I graph it, I'm going to graph it with an open dot at that 0 point because it's strictly less than 0. So I'm going to use it, although I'm going to use an open dot saying I'm going to get infinitely close to that point x equals 0 there, but technically I'm not going to touch that point 0. That's why I'm using that open dot. So I'm going to choose 0 and any x value less than that. So 0, -1, -2, and -3 will be the 4 points I choose to do here. Plugging in 0, I get 0 squared equals 0 plus 3 is 3. I got -1 squared is 1. The negative makes it negative, so -1 plus 3 is 2. I have -2 squared, which is positive 2, positive 4. And then the negative makes it negative, so -4 plus 3 is -1. And then 3 here, -3 squared is 9. The negative makes it negative, so -9 plus 3 is -6. Now I can graph that point. Remember, open dot at this x is the 0, 3 point because x cannot actually equal 0. So I go over 0 up 3, and I got my first point right here, open dot. And then -1, 2, so I go over 1, up 2, so right there, and then over 2, up 1, right there. Oh, that's -1, sorry. So I got to go over 2, down 1, and then over 3, down 6, 1, 2, 3, 4, 5, 6. And there's that first part of my piecewise function there. Now I'm going to do an xy table for the second portion of it, for the second function of it, and that is going to be xy. I'm going to try to scroll down here if I can. Oh, if I can, geez. xy for the function 3x minus 5. So this is for this 3x minus 5 function. And this time I'm going to use 2 and everything greater than 2, and I'm going to use 2 in my xy table, and I'm actually going to be able to graph it with a closed dot because we're talking about x equaling 2 and everything greater than that. And so I'm going to use 2, 3, 4, and 5 here. And again, when I graph that point at x equals 2, I am going to be able to use a closed dot because that is greater than or equal to 2. And so plugging in 2, I get 2 times 3 is 6 minus 5 is 1. 3 times 3 is 9 minus 5 is 4. 4 times 3 is 12 minus 5 is 7. And then the pattern is up by 3 every time, and it's constant linear growth. So I know it's 1, 4, and 7 there, and I can graph these over 2, up 1, over 2, up 1, and that is a closed dot there. It's a closed dot because of that greater than or equal to. And then over 3, up 4, 1, 2, 3, 4, get a point there. 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And then the last one is at 5, 10, so I go over 1, 2, 3, 4, 5. Up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just at the edge of the graph. And I can draw my straight line through that the best I can do here. Okay? And that would be my piecewise function graphed. The toughest thing is making sure you do an xy table for both, and then just make sure you're using those open and closed dots where accordingly I used a closed one at x equals 2 because, again, 2 is included in my domain. I use an open dot here at 0, 3 because 0 is technically not included in my domain. Just because it's not technically included in my domain doesn't mean I don't want to include it in my graph, though. All right, so there's my video for number 11. If you have any questions on the piecewise, let me know.